In this video, we're going to be talking about Java primitive types. Now, exactly what are Java primitives? These are special types that are very efficient. They are actually the most efficient variable type to use. Java stores primitive variables directly in memory. So this is very important as to how the Java program is going to be very efficient. This really does help with the efficiency of processing with Java because of how the primitive values are being stored. It gets them a little bit closer to the native hardware and whatnot. It allows Java to be much more efficient on the platform that it's running on. Non-primitive variables use references to where the value is stored. So this is a little bit different. This is really the inner workings of how the JVM is working with these different variable types. So the key takeaway is remember that primitives are going to use less memory and also be more efficient to access. So wherever practical, you want to be using primitives. And I say practical because the reference types they do have their benefits, and we're going to see quite a bit of reference types coming up. But the primitives are a very important part of the Java language. And if you're doing something that is looping and going over things quite a bit, I definitely want to be looking at using primitives because of their efficiency. Now, here's a list of the Java primitives. There's 8 different primitive types. You can see that we have the value for a Boolean that is simply true or false, and that takes up 1 bit in memory. A byte, that is an integer, and that also takes up 1 bit in memory. And you can see that a byte can have a value of 127 to negative 128. Then a character, this is a Unicode character. So Unicode is A through Z, and then a suite of special characters, and I'll share additional information with that or about that coming up in a different video. But here, these are ASCII values, 0 to 256. And then a short, and this is also an integer, and this takes up 2 bytes of memory. And you can see this is roughly 32,000 to negative 32,000. And then an integer, this is takes up twice the memory that a short does. And you can see I have scientific notation there. It is a larger value. I'm not going to figure out the scientific notation there. And then we have a long. This takes 8 bytes of memory. And with the 8 bytes being that it takes up double the memory of an integer, that is going to hold a much larger number. And then finally, we have their cousins, float and double. These are floating point numbers. So the short, int, and long, these are whole numbers. They don't have any decimal precision, where the float and double do have decimal precision. And key takeaway there, you can see that the float takes up 32 bits, and you can see the scientific notation there. And the double is going to take up 64 bits. So obviously, that's going to be a much larger number that you can store in that value. Now, you can convert data between the different primitive types. This is known as casting. There's 2 types of casting. One is implicit, where the casting is implied. The magnitude, the larger part of the number, is always preserved. But the precision may be lost as far as the decimals. Those could get truncated. So this is going to happen automatically. You don't have to declare it. So if you are going between types, this can happen without your intervention. Explicit is where casting is declared. You are explicitly going to declare this. And this is something that you have to be careful with. This can definitely get you in trouble if you're not paying attention. But it is also handy where you don't need that magnitude to be preserved, or you are aware of the consequences of your actions. So just remember that explicit, you are going to declare it. The magnitude might not be preserved. So think about if you're going from a larger number into a smaller container, you're not going to get the larger value stuffed into there. So just how the application is going to work. So you go from a long that is taking 64 bits into an integer that takes 32 bits, you're going to wind up with the maximum value of 32 bits. Now let's take a look at the table of the explicit casting. So this gives you an idea where I have, let's see, take a look at the character going from top to left. You got the from Boolean byte character, and you go down to byte. You can see that the character, that is a cast operation. So wherever I have a cast operation, this is where you have to do explicit casting. And if there's no value, that's where implicit casting is going to go ahead. go ahead and happen for you. So this is a table that you can print off and keep for your notes and use it as a reference. Now, the Java primitive types all have corresponding reference types. So for example, Boolean, the all lowercase Boolean type, is going to have a reference type, and that just starts off with a capital B. Again, the character, CHR, that is going to also have a corresponding reference type, and the same with integer, and so on. I think you can see the pattern there. And just remember that the reference types can be much more costly. They can consume a lot more memory and can be slower to access. And reference types, there's a lot of information on those, and we are going to cover that in an upcoming lecture.